Hello guys, this is Doctorbass and today I'm making a little video for you to see um, what's the latest improvement on the charger pan that I've designed, and also some explanation about how I build it and why it is built this way. So let's see the pan itself. This is the prototype, okay? So that's why it's not very good, and those have been plied by myself. It's 316 thick, so just give you a good idea on how difficult it was. I had to drill those holes to make it easier to bend. But this is the prototype to see if it fit on the zero. So here is the CAD version. So you see it here. And well, the first idea was to make it with very thick aluminum. In fact, it's 316. And the reason, the very first reason, is for heat dissipation and also conduction, I will say. Because the goal is to take the heat generated by those, which is mostly on the middle part here. This part get very hot, and as you know, the bike is static. When you charge, I'm here. When you charge the bike, as well, you're not running with it, so there's no airflow. So it's important to have a great convection of that airflow. So my goal was to build a pan like this, and to let the user, depending on the region, the area where you live, if the outside temperature is very warm, or if it's like in Canada, where it's, well, sometime warm, sometime very cold, sometime cold. So depending on the situation that you have, you will have the option to add some heatsink on the side here. Okay, the clearance from the motorcycle when you tilt it is very enough. So even adding heatsink here, it will not touch to the ground. Okay, that's important. I don't want it to make the pan very large for that reason. So I've got a big heatsink here, as you can see. This is recycled parts, so I might just cut some length of those heatsink and take those and put these right here with the fins oriented this way vertically. This is very important because when the fins on the heatsink are vertical, they they get better air convection, because the air goes from the lower part to the upper part, because as it is in contact with each fins, it will heat and goes up. So you want to have great convection. Okay, so the fins might be this way, and I've evaluated the surface area that this charger pan will add to this charger, and it's a lot. In fact, you have two surfaces if the charger is installed right here. I'll give you an example. I will take this one. Okay, put it this way. All right. Okay, so the heat it will produce will be produced also here. It will be dissipated by that surface, but the thickness here of that pan is enough to have great conduction of the heat through this surface too, as well as this surface and the other surface here. That's the goal, okay? I want the heat to be spread on the largest surface as possible, and this pans have a lot of surface, okay, on both sides. Okay, so if the heat dissipates this way, it will also dissipate this way. So installing some blower on any particular area just to have airflow might also help to evacuate this warm air inside the pan. But the pan will not be perfectly sealed. It will be, I will say, it will isolate from rock projection from the wheel because, you know, I will show you. This is my 0 and the pan will locate right here. What I want is to avoid the rocks projection from that front wheel here to hit the chargers inside. So the pan will just slip under this fairing here. So even the rain or the rock will not go inside the pan because the pan goes inside here with that angle, goes this way, and then where the motor is, it goes this way, and it's just very close to the fins but not in contact. So the projection from this wheel will not goes into the charger too, okay? As well as the water, yeah, as well. It's not perfectly sealed, and I don't want it to be sealed. I want to have some airflow inside and circulation. So the goal is to have most isolation from projection and to have minimal water intrusion. But the chargers themselves are IP67, if I remember correctly, or 68 maybe. So these are already sealed. So even with some water on the bottom here, it's not a big deal, you know. And the pan will have these holes here on each of the corner. What it makes is that when you park the motorcycle, it will be tilted a little bit, just this way, and water will just get through one of those. So it will be perfect. And as you can see here, okay, the pan will have 4 holes here for the center holes here, and 4 other holes for the attachment right here. So each of the chargers will be perfectly in contact with the bottom surface. This is to have maximum heat contact between the bottom of the charger and the pan surface, okay? And I've specified the manufacturer to have very great flatness here, no wave or something like that. So guys, I hope you appreciate, and is there any other details I could just explain to you? Well, maybe one more. You see here? Okay, yeah. This particular shape is to accommodate, I think it's the stand or the brake pedal that is very close here. And the other side, you see, well, alright, okay, so we see it, great. This side is, I think, for the stand, the quick stand. Okay, I will show you on the 0. You see this shape here. So the pan will match this with a minimum of clearance to avoid some tolerance problem with tolerances on the holes and the position of the pan. So that will be the final version, and it will be black anodized. That will make 2 things. It will make it a little bit stiffer because anodization add to rigidity, and also it will help for the heat transfer, because this color of aluminum is not a very great black body for heat transfer, so anodized aluminum will help a little bit more, and also it will match the motorcycle frame. So again, thanks for watching, guys, and I hope you enjoyed. Bye bye.